this video we're going to look at combining like terms. So first let's just get an idea of how to identify a few things in an expression. So 7x plus 3x minus 5x plus 8 plus 4x minus 1. Alright, so what we want to do is identify a couple of things. Let's start with this. A variable term. Now, when we say term, here's how you tell where a term starts and ends. A term is essentially going to be separated by a plus and a minus sign. So if we go and look at all these pluses and minus signs, it tells you where all the terms are. 7x is a term, 3 is a term, 5x, 8, 4x, 1. All those are terms. Okay. All right, now let's back up a little bit and let's talk about a variable term. Now, we've all probably heard of what a variable is. Essentially, a variable is just a letter, okay, in basic terms. All right, now, a variable term is just the letter and any number that's in front of that letter. So, 7x is a variable term. 5x is a variable term, but we also want to just notice this minus sign in front of 5x is going to make it negative. And then 4x is also a variable term. So if we wrote down our variable terms, 7x, negative 5x, and 4x. Now let's go a little bit deeper and say, okay, what is that number in front of x? That's called a coefficient. So a coefficient is just the number that's in front of your variable. So if we say our variables are x, that means that 7's in front of x, negative 5 is in front of x, and 4 is in front of x. So our coefficients would be 7, negative 5, and 4. And then the last thing is a constant. Essentially, a constant's just a number without a variable. So like in this problem, the constants would be 3, 8, and negative 1. All right, now we've gone over that, so let's actually dive into how do we combine like terms. So how do we combine like terms? What are we looking for? Okay, so here's what we're looking for. So once again, how to combine like terms. Okay, here's what we're looking for. We're looking for essentially two things. We're looking for terms. So we want our terms to have the same variable, and, so this is not an or, this is an and, which means two things have to happen, same variable and the same exponent. Okay, so that's the only thing you need to combine like terms. Now, just know this, when you combine like terms, we're basically adding or subtracting. So we're going to be adding or we're going to be subtracting. That's really all we're doing. So we're just adding and subtracting. And then we'll talk more about what happens when we do the actual adding and subtracting, but we're looking for two things. Once again, same variable, same exponent. So let's look at some examples. And this will start off easy, and then maybe we'll try to make it a little bit harder. All right, let's go with an easy one. 3x plus 6x. So it would say something like simplify. Simplify. Okay, now, if I'm simplifying 3x plus 6x, my first question is, do these two terms, because remember, terms are broken up by adding and subtracting. So there's two terms here, 1, 2, 3x and 6x. Do those two terms have the same variable? Yeah, they both have an x. Okay, do they have the same exponent? Well, the question is, if x is by itself, what's the understood exponent for x? Does anybody know? It's actually 1. X to the first power, we can just write that as x. So, if this is to the first power and this is to the first power, then yeah, we have the same variable. So same variable, I'll just abbreviate it. And we have the same exponent. So if that's the case, we can add these two together. Now, when you add like terms and there's a variable, all you have to do is add the coefficients. Okay, so what's 3 plus 6? It's going to give me 9. And then when you bring down your variable, the variable doesn't change. The power, the exponent doesn't change. So when you add like terms, if there's a variable, add the coefficients, but keep the variable the exact same. So this would be 9x. I'll show you an example when the variable goes away, but it's a pretty easy one to understand. So let's continue, because that one I bet was pretty easy. Let's go with 9a minus 10a. Okay, so let's simplify. Are these two like terms? Do they have the same variable? Yeah, they both have an a. Do they have the same exponent? Well, what's the exponent of a? 1 and 1. So they are the same. So that means we can combine these two. So we take 9, subtract that by 10. So what's 9 minus 10? It's negative 1. And then we bring down our a, because once again, the variable is not going to change. Now, the other way you can see this written is just with the 1 left out. We can say negative a. All right, let's go. Let's do another one. Let's say, let's make things a little bit harder. Let's say 7p minus 1 minus 9p plus 5. All right, now this one's a little bit trickier, but let's try to do it. And if you want to, just pause the video and try this on your own. So now let's start with 7p. The 7p have another term or have a like term in the rest of this expression. First of all, there's 4 different terms, because if you look, our minus and our plus signs are going to break this up into 4 different terms. So now we're trying to look for another term with p in it, and there is one. It's 9p. All right. Now, do those p's have the same exponent? Yeah, they do. They both have an exponent 1. So if they both have an exponent 1, then that means that we can say 7p minus 9p. And you may be asking, where the heck did I get the minus from? Well, if we go and we look at 9p, to the left, there's a minus sign there. So that minus sign has to stay with 9p. I can show you why real quick. Remember that if we were to make this plus, then the negative would go to 9. So it would be plus negative 9p, which is the same thing as minus 9p. All right, so let's back up. So now that's going to give me negative 2p. All right, so now here's some advice for you. Once you get finished with a like term, I would cross it out. So let's cross that out. Now, let's look for another set of like terms. And for this, if you notice, I underlined my first set of like terms once. I would underline the second set twice. And then you could do it 3 times, 4 times, and so on. All right, so now when we check for negative 1, do we have another variable? Well, do we have another term that has the same variable as negative 1? But negative 1 doesn't have a variable. So we're just looking for another term that doesn't have a variable, which is 5. Negative 1 plus 5, you can add those two just like we would normally add them. So we can say, down here, we can say negative 1 plus 5, and that's going to give me 4. And since it's positive 4, I'm going to add in between my 2 terms, and actually, this is my answer. Negative 2p plus 4. All right, let's try another one, because maybe that one's a little confusing. Let's do a couple more. All right, let's say we have, let's do x's and y's, because those are commonly seen. 5x plus 7y minus x plus 2y plus 3x. All right, let's see what we can do here. So let's start with 5x. Is there another term in this expression that has an x in it? Yeah, we have negative x and we have 3x. So what we're really doing here is 5x minus x plus 3x. So now my question to you is, when I do 5x minus x, I need to know the coefficient that's actually right here in front of x. So what is it? It's actually 1. If you see a variable by itself, the understood coefficient is 1. So this is like saying 5 minus 1, which would give me 4x. Then we're saying plus 3x. So now I'm saying 4 plus 3, add the coefficients, and then bring down x. So that's 7x. Now we can go back to the very beginning, and we can get rid of everything we just used. Okay, so now 2 underlines for 7y for my next variable. Let's see if there's anything another term that has a y in it? There is. There's one right here, 2y. So what I'm really saying is 7y plus 2y, and what's that going to give me? Well, I add the coefficients, 7 and 2, which gives me 9, and then I just bring down my y. Now, if that's a positive, I'm going to add in between my two terms, so there's my answer. All right, let's look at a few more situations just so you can see. Now, the next situation I'm going to give you is a little bit more complex, but I think a lot of you can handle it. What if I gave you 5x squared plus 7x squared? Well, let's go through the process. If these are like terms, that means that they're going to have the same variable and exponent. So do both of these terms have x? Yeah, they do. Do they have the same exponent? Yeah, they do. It's 2. So, once again, you're going to add the coefficients. 5 plus 7 is 12. And then you just bring down the x squared, the variable, and the exponent. So once again, when you're combining like terms, when you're adding and subtracting, never change the x squared and y squared, or x squared or y squared, or whatever it is. Once again, I'll show you in a second the only time it goes away. Let's do this. Let's make it a little bit harder. Let's do, actually, maybe we'll make this the last one. So let's look at, let me get a good color here. Okay, let's look at 8k squared minus k minus 5k plus 7 minus 2k squared. All right, now this is going to be a little tricky, but let's see if we can do it. So let's start with 8k squared. Is there another term that has a k in it? Well, yeah, a ton of these do, but we specifically want a k squared because remember, we want the same variable and the same exponent. So now let's try to find another term that has k squared as the variable. And we do. We have one right over here. But once again, pay attention to the sign. What we're really going to do is 8k squared minus 2k squared, and those are my like terms. So subtract the coefficients. 8 minus 2 is 6, and then bring down k squared. And now we can go back and mark all these out. Okay, let's try to find more. So now let's start with this negative k, and let's underline that twice. Is there another term with k in it? Yeah, it's right here. It'd be 5k. So if I say negative 1k minus 5k, that's going to give me negative 1 minus 5, because once again, we are going to focus on the coefficients. So negative 1 minus 5 is going to be negative 6, so I'm going to say minus 6, and then we bring down k. So bring down the variable because it doesn't change. And then we can mark those out. And then the only thing we're left with is 7, so that 7 has to come down. There's no like term for it. So plus 7, and we're done. All right, let me show you one more example just to show you when a variable can go away. Let's say I have, I don't know, 3x minus 3x plus 5. Okay, what are the like terms? 3x and 3x, because they both have an x, both terms have an x, and they both have the understood exponent 1. Now, what happens if I do 3 minus 3? Because remember, I have to combine the coefficients first and then just tack on the variable. So what's 3 minus 3? Well, it's 0. If I say 0x, here's what I'm technically saying. I'm saying 0 times x, because a coefficient is multiplied by the variable. So if I say 0 times x, what's 0 times anything? Well, it's just 0. So actually, this is just going to go away. It won't be 0x. 0x is just 0. So then I'm only left with 5, so my answer to this will actually be 5. All right, so once again, remember, for like terms, you want two things to be the same. You want to have the same, for some reason my colors won't work. There we go. You want to have the same variable, and you want to have the same exponent.